All right, let's talk plate tectonics. You probably remember it from school, right? This idea that massive chunks of the Earth's crust are always on the move. But what if I told you the reason they move is way simpler and a whole lot more powerful than that old textbook model? Today, we're going to flip that old idea on its head.
So when I ask that question, what's the first thing that pops into your head? For most of us, it's this image of a giant conveyor belt, Magma bubbling up in the middle of the ocean and just shoving the continents apart. It's a decent picture, but it turns out it's missing the real hero of the story.
Yeah, that whole idea that the plates are mainly being pushed apart, it's not the whole story, not by a long shot. The real driver isn't some mysterious hidden force churning away down below. Nope, it's something much more fundamental, something that actually runs the entire universe.
And asking this question changes everything. Instead of hunting for some kind of magical force, we can just ask a simple physics question. See, the Earth is basically a hot ball sitting in the freezing cold of space, and it's constantly being pulled on by its own gravity. And just like a ball rolling downhill, any system wants to find its lowest, most stable energy state. It just so happens that moving continents around is the planet's most efficient way of doing exactly that.
Okay, so let's take this new energy perspective and check out our first suspect, what we call ridge push. We're going to head out to those mid-ocean ridges and see what's really going on.
First things first, let's just get that word push out of our vocabulary for a second. It's not really a push. A better way to think about it is that a mid-ocean ridge is basically a giant underwater mountain range. The brand new rock that forms at the top is, naturally, higher up than the older rock that's further down the slope. So ridge push is really just gravity, doing what gravity does, gently pulling that higher rock downhill. That's it. No mystery engine needed.
And here's how it works, step by step. Hot, buoyant stuff from the mantle rises up, creating new crust at a higher elevation. As that new crust moves away from the ridge, it cools down. And what happens when things cool off? They get denser, right? And they sink a little bit. And just like that, you've created a very, very gentle slope. Gravity takes it from there, letting the plate slowly slide away. It's a completely natural process.
So, here's the key takeaway. Ridge push is absolutely a real thing. It's happening constantly. But it's kind of weak. I mean, the slope we're talking about isn't exactly a cliff face, so the amount of energy you get from that gentle slide is pretty small. It's a contributor, for sure, but it is not the main engine driving this whole machine. No way.
All right, on to our second mechanism, slab pull. Now this is where things get really interesting. We're talking about subduction zones, those places where one tectonic plate takes a nosedive and slides underneath another. And when we look at this process through our new energy lens, wow, it is a completely different ballgame.
And again, let's ditch the old language. It's not being pulled by some invisible string. It's much simpler. It's a massive, incredibly dense object that is just falling. One source I read compared it to dropping a heavy steel plate into a giant vat of honey. Once it starts sinking, gravity just takes over, and that motion becomes unstoppable.
So what makes this falling so unbelievably powerful? Well, it's all about what the slab is made of. We're talking about oceanic crust that is millions and millions of years old. It's had all that time to just sit there and cool off, which makes it incredibly cold, thick, and way, way denser than the hot, gooey mantle it's sitting on. It's basically a giant, heavy rock just primed to sink.
And this right here is the heart of the entire argument. As this super dense slab sinks for thousands of kilometers deep into the Earth, the amount of energy it releases is just colossal. I mean, think of the energy difference between rolling a bowling ball down a tiny ramp versus dropping it from a skyscraper. That massive drop in energy is the real engine we've been looking for.
Okay, time for the main event. Let's put these two processes head to head, ridge push versus slab pull. And let's see what the simple, undeniable physics of energy tells us about who the real winner is.
And honestly, it's not even a fair fight. On one hand, you've got ridge push, with its small height difference and shallow slope, which gives you a small energy release. But on the other hand, you've got slab pull, with its huge depth difference and massive density contrast, which unleashes an enormous amount of energy. It is a total knockout.
And this is the bottom line. The universe is always going to follow the path of least resistance, the path that releases the most energy. And the energy drop you get from a slab sinking into the mantle is on a completely different scale than the gentle slide off a ridge. This isn't just a geology theory. It's a fundamental law of physics playing out on a planetary scale.
So with the verdict in, we really need a new mental picture for how this whole plate tectonics thing works.
one that puts the real engine in the driver's seat.
You know, if you're having trouble visualizing just how big of a difference we're talking about, the source material had this brilliant, simple analogy that makes it all click into place.
Imagine a tablecloth spread out on a dinner table, but one end is hanging way off the edge. Ridge push is like the gentle slope of the cloth that's still resting on the table's surface. But slab pull? That's the heavy, hanging part that's falling towards the floor under its own weight. Now tell me, which one is actually pulling the rest of the cloth across the table? It's the falling part, every time.
I just love this quote. It distills this whole complex idea down to its elegant core. The cooling at the ridges, that gives you the motion. It creates the gentle slide. But the falling of the slab into the mantle, that's what gives you the power, the immense system-driving power.
And that brings us to the most crucial point. Our old model was basically backwards. We thought ridges were actively pushing plates apart, but that's not what's happening. The sinking slab is the engine, and it is dragging the rest of the plate along with it. The spreading we see at the mid-ocean ridge is just a passive consequence of that powerful pull happening on the other side.
And in the end, it all comes down to this simple but kind of profound truth. The Earth isn't trying to do anything complicated. It's just obeying the most basic rule in the entire universe. Heavy things fall. And the slow, majestic dance of the continents is really just the planet getting out of the way.